the heavier elements in our world, like gold, silver, and uranium, come from another type of supernova. A single-star supernova. This is our sun. A single star has to weigh much more than our sun to go supernova. And there are some monster stars out there. Some are dozens of times heavier than our sun. And some are hundreds of times more massive. The heavier the star, the faster it burns. And when these massive stars begin to age and die, the nuclear reactions inside them speed up.
Giant stars burn through their nuclear fuel very, very fast. It's sort of the live fast, die young. The more mass a star has, the hotter it burns inside, the faster it burns through its fuel.
Unlike double-star supernovas, really massive single stars create lots of elements before they explode. Once they turn hydrogen into helium, helium into carbon, and carbon into oxygen, they don't collapse into white dwarf stars. Instead, giant stars keep on burning, building up layer after layer of new elements deep in their core.
Big stars don't stop after they've burned helium to carbon and oxygen. They go ahead and burn carbon to still heavier elements, and then neon and oxygen to silicon, until you get this nested Russian doll spherical layer cake kind of thing.
These elements are the building blocks of the universe. But they're trapped inside the giant star. Somehow, they've got to get out.
Studying exploding stars has taught us how the heavy elements of the universe came to be. They were formed by nuclear reactions inside stars. But if some of those stars were not to explode, then those elements would be locked up forever.
The trigger that will release the elements in the single giant star is the same element that causes the Type 1a supernova to blow up. Iron. Iron eats up all the energy of the star's nuclear fusion. Without the energy from nuclear fusion pushing out, gravity begins to crush down. The big star is doomed.
The last moments of a star are really phenomenal. The star might last for 10 million years on the way to becoming a supernova, but the last little bit takes place very rapidly. Once you have an iron core and once it gets out of balance, it collapses in a thousandth of a second, a millisecond, from the size of the Earth down to the size of Manhattan. It's traveling about 1/3 of the speed of light as it crunches down.
As the star becomes unstable, the massive power of gravity causes the core to collapse. This happens with such incredible power, even the atoms inside start to crush together. As it gets smaller and denser, the core builds up more and more energy.
It's something with about 1.5 times the mass of the sun that has collapsed to something that's only about 15 miles across. It's got incredible density. It's 1,000 trillion times the density of water.
Now, the star explodes. blast rips through the star's outer layers, and in the process makes all the elements heavier than iron. Iron becomes cobalt. Cobalt becomes nickel. And on to gold, platinum, and uranium. The explosion is so brief, it only makes small amounts of these heavier elements, which is why they're so rare. The supernova blasts these new elements billions of miles into space.
The only method we know, the only mechanism that we have found anywhere in the universe for creating new elements is in the death throes of a star called a supernova.
It seems